Guys, welcome back to one more video. In this video we'll be discussing about virtual thread versus thread, and as you can see in my screen I already ran the virtual thread against the executor service, which is nothing but behind the scenes it has threads, and I ran against 1000 threads real time, and you can see here the data over here. So let's go over the data first and then we'll try to debug each and every point. So watch the video till the end, don't go anywhere in the middle, otherwise you won't understand anything. So you can see here the date and average times and everything, and the most interesting part is the throughput. You can see the throughput, so it can handle 12.1 requests per second, and whereas if you compare with the executor service, which is behind the scenes, it has the threads or the OS thread, it can handle just 9.8 requests per second. So this is how it creates the lot of difference. So in the screen I am sharing the JMeter results, and if I go to the graph, you can see here there is a different graphs you can plot against this data. Now from where this data came, right? That's the first question. Now if I go to here, the first, and this is the second use case. These two are the use cases which I am running. So you can see here I am running HTTP request. This is the local host, this is the port, and this is the controller or the API, I would say, REST endpoint I am calling. So I am calling this REST endpoint 1000 times with a loop of 5, and same thing is the executor service. So the executor service behind the scenes, it has the threads, and again I am running 4000 and with the loop of 5, and if you see here I'm calling this endpoint, and which is getting hosted in localhost 8080. So these are the two scenarios I'm running, and if I run this, and you can see here this is the reports for each of them. So I just click on the summary of JDK 21 virtual thread versus this is the summary report of JDK 8 executor service. There is a lot of difference, as you can see here. So there is a lot of benefits if you use the virtual thread, which is you can see here from this graph as well. So we should understand what is virtual thread, and we should implement in our applications if possible. Now to get started, let's start with the JMeter first, because this is the interface we need to test all our scenarios or replicate the performance scenarios. So to do that, you have to go to a website for the JMeter to download it. So once you download, it's totally free. Once you download this, you can again come back to the video. All right, once you download and unzip it, right, you will get this kind of structures. Now just go inside this and go to the bin folder, and there will be a file for Windows. You can see here JMeter W, and based on your requirement, you can click on any of the files. We have sh, and this is the Windows JMeter Windows. Once you double click on this, you will be seeing this screen. And once you have this screen, what you'll do, let me do one thing. Let me just cancel it. So let me just double click on this, run it. Now once you have this, you'll be this kind of scenario you'll see. Now in this, you just click on the open, and in open you can see here, if you go to my IntelliJ, I'll be pasting each and everything in the GitHub repo. Now just click here and click on Explorer. You can see here this guy is placing over here in your workspace. Now just go here once again and give this path, right, and import it. That's all. So you'll have this all the test scenarios so that you can run your APIs. And once you're set, you just click on, once your service is up and running. So you can see here my service is up and running, so I can go ahead and run on the green button. So this is my green button. You can just run on this, click on this and just run it. So once you run, you can see the aggregate values, and then you can compare your applications. Now let's go to the code and try to understand virtual threads, how I have declared. And at the end of the video, I'll explain what is virtual thread and what is thread, the entire pictures. So I have different pictures here. I'll just go over it. But before that, I just want to show you the coding portion of it. So for this, you must need JDK 21, right? And you have to create some of the beans. Now this beans, first bean is the executor service. I hope you know about the executor service. Is nothing but in JDK 8 they have introduced, or maybe earlier, I forgot which version they have introduced the executor. But the executor, right, that is the place where we'll be creating the new virtual thread. So if you, this command if you do, right, we'll go over what is virtual thread in theory, but once you do this, it is ready totally. There is nothing much you have to do. And there is, in the olden days actually, we used to create the executor service with the thread pool. So there are different ways you can create the thread pools. I'm using the fixed thread pool, and you can see here there are two bins are there. The reason why I have two different bins, because I want to customize my thread and make sure that whatever the thread being created by my executor service, it should have the highest priority. So, and the way we have to define the priority, just go inside this. We have to implement this thread factory, and this thread factory you can pass into the executor service. I hope you know about this, right? Now, and to make it all the threads which were being created by this thread pool, how to make this as the highest priority, you can just put this entry. And sometimes we want to make sure that the threads should have a proper naming convention. For that, I have just given my prefix name, so that in, let's say, you have a Splunk logs, or you have any Datadog or something, right, you can see your logs very clearly that this is my thread being spanned across by this executor service. So that's the reason it's very easy to debug the different scenarios. So that's the reason I am given the name. So you just see here, I've just given Mrigang custom thread. So these are the main reasons, and there are many things you can do with the threads. You can set out the timings, define timeouts, and all these things you can do with this, right? So that's the reason it's very important to make sure that the executor service has the proper implementation of uh, thread factory, right? And there is, if somebody is not interested to do this, that's okay, and that is totally fine. You can just pass this bean to the APIs. I'll just go over the APIs in a moment, right? Now let's go to the service. So this service, if you can see here, it's a time consuming service, in the sense, let's say you have a database call or something. I just kept a simple service which will take some processing time, so that's the reason the name is blocking service. So it's ultimately it will take some time to process something. It can be anything. It can be processing a asynchronous call, or it's a database call. It can be anything, any other API also, right? Now let's go to the controller. This is the main place where we are passing the different executor services. Now you can see here, before I go to the controller, right, it has executor service, and I'm just giving the different qualifiers. And this qualifier, OS platform thread executor service, if I go here into my configs, in the config you should see this one of the bean name. So let's go here and go to my thread config. Let's search by this name. Yeah, so this is the name of this executor service, which is the default one, right? Let's go to the controller once again. This is the this is the controller. Now this is the custom one. This custom one, where I have given the custom name. In this case, I have given my name, Brigank, and then I am passing that across the API, which I'll show in a moment. And then this is the virtual thread. So not much changes, just with the executor service you have to play around. Now these are the two APIs, and these two APIs, it's doing ultimately the same thing. Same thing it's passing. I'm sorry for that. Now if I go here to my this, so you can see here JDK 21, and just expand this and click here. You can see here I'm calling this endpoint. Now just copy it and then search for this guy. You can see here I'm calling this endpoint. Now these two, as I said, right, these two APIs having the same functionalities, same thing, right? Just I'm passing invoking. So I am invoking the blocking service from here. So as you can, I hope you know about this, right? How we have this callable, right? So it basically return back something, or we call it as a future also. These futures I'm putting into a task, and these tasks I'm executing via the executor service, which is nothing but the virtual threads. Now these futures, again, I have to just call back and get the entire list. So this is what I'm doing here. So it's a joining of all the threads, right? And then I'm putting the results into the results. That's all. Now this is about the virtual threads, the API, nothing fancy. Now JDK 8 executor service, again same story. If you see, this is the API I'm calling, just copy it and again search for this. You can see here, this is the API. Again, it's doing the same thing, right? I'm calling this blocking service process method. This process method I'm calling it, and I'm passing the executor service with the custom factory. You can change this to any of the executor service. For example, I'm passing this. Let's say you want to pass this guy OS platform, right? You can pass with this, should not be a problem. You can pass this, but the main, the benefit what you'll see in the logs with some custom names. And ultimately I'm passing this callable futures, and these callable futures I'm again getting back all the results. Basically I'm doing the join. So once you do the join, all the threads will wait for the completion, and then this is the result you will get out of it, right? And the moment you will see this, make your service up and running. And once your service is up, you just let me just clear it, right? And test it by hitting the API endpoint. You can just hit this, and okay, only one thread, right? So it's showing success. And if I go down here, you can see here the current task is running by this thread. This is the name of the thread, so I have given my thread name. So that is how it is making sense that we can put some meaningful name, thread name, right? In case of virtual thread, let's run it by virtual thread. So if I go here, this API, this is the virtual endpoint. I just run it, and you can see here the current. Okay, in case of virtual thread, I think nothing, because it works on the carrier thread. I'll explain what is virtual thread and what is the OS level thread, right? So this is the virtual thread logs. Now the main important, you can see now, you can decide, right, which one is better, virtual thread or the actual thread, because we have the results and everything, right? Now the question is why virtual thread is more, or it is far better than the any other thread. So what is thread? So thread, if you just a very normal terminology, right? Let's one person is working in a team, that means it's a one single thread. Let's say 2 persons or 3 persons are working in a team, in the same team there is a manager, right? So that means there are multiple people can work on multiple different things, and it can be, each and every work can be done parallelly. So that is the multiple threading, right? In OS world, the threads are being handled by the OS level or the kernel level, right? So as you can see here in this screen, so this is the factory manager I can see here, right? This factory manager is nothing but your OS, right? And if we compare with the OS scheduler or the OS kernel, there can be the word processor, there can be, if I listening some songs, that is also one more thread it's running. If I'm running some Java application, that is also running on one thread. So everything is managed by the OS scheduler or the kernel, right? So that is nothing but the relation between the OS thread and threads, right? Now how the JVM it works with the threads, right? That is the main question, right? So if I go here, the second slide. Now let's say your Java application, right? It requires threads. There are, because Java all totally works on the threads. It has daemon threads, it has Tomcat threads, a lot of threads are required. And whenever it requires a thread, or the JVM requires a thread, it's just send a signal through the JNI and call for the OS kernel. Then, hey, I need these many threads, or I need these many threads to process. So after all, those three threads are being processed by, or the entire um, each of the threads are at the OS level, not at the JVM level. So you just try to understand what is the difference between the threads which is requesting by the JVM, and the threads are totally maintained by the OS level. So it's not the life cycle of the threads are managed by the JVM, but it's by the OS. So, and it is, JVM is basically requesting by the JNI calls, right? Now let's go to the virtual threads. Now in case of virtual threads, the entire since as you can see, the name itself is virtual thread, right? So it is managed by the JVM itself. So there is no context switching or anything, because in case of other case there is a context switching. There is a because the entire life cycle is getting managed by the the OS level, right? So that is the hiccups are there. But in case of JVM, the virtual threads are being managed by the your JVM, and JVM itself, it works on the, so these virtual threads are works on the carrier. So these carriers are nothing but the OS level threads, right? So and JVM, it just create lot of threads, and then with the help of all these carriers, it totally works like seamlessly, because no need to interact directly with the OS level, so it can handle everything on the JVM level. That's the reason it's very fast, right? Now, if you see here, I mean, this is more about the interview questions, like what is the difference between the platform threads and the virtual threads. I already explained, right? Platform threads or the OS threads are at the OS level. It is totally managed by the OS, or it has one is to one relationship with the OS, or there is a context switching. If JVM asks for it, then there is a context switch happens, and then it will be total life cycle will be managed by the platform threads. Now, virtual threads, on the other hand, it is totally managed by the JVMs, right? And it works on the carrier threads. Carrier threads are nothing but your JVM already. Some OS level threads are there. On top of that, the virtual thread always plays as a home ground. So that's how the virtual thread and the platform thread, that is a difference. All right, so this is about the virtual thread and the key difference between these two. And I hope this video will help many people to take the decision which one to take. And last but not the least, our, if you see our Tomcats, right, our Tomcat server is running on the actual threads, or so there is a thread pool is there behind the scenes in the Tomcat. Now, those Tomcats service has a thread pool limit of 200. You can search in the Google also, right? It has a thread pool limit of, by default, actually you can change it. That's not a problem, but it's a by default 200. So anything more than 200 threads, let's say in this case, I am asking for 1,000. I'm asking for 1,000, right? Here I'm running for 1,000 with ramp up of 5. So in this case, right, whatever the JVM, not GVM, sorry, the Tomcat level threads are there, which is by default 200. It will be obviously, it will be increased, right? And remaining everything, it will go on the queue. Now think about if you are in a batch, right, where your service, which is in this case, I have given this blocking service, which is consuming a lot of energy or a lot of power, right? And it is taking a lot of time. So in that case, in the in Tomcat, all other threads which is more than 200 will go on the queue. And it sometimes, if it doesn't come out right, it will be more problematic, right? So in those cases, maybe you can try with the OS level, sorry, on the JVM level threads, which is nothing but the virtual threads. Now, to convert that virtual level threads, basically the Tomcat thread as a virtual thread, there is a very small tweak you have to do. Just come here and uh, just add the Spring thread virtual enable true. So this is again provided by the Spring in the latest version, and you can try this once and see the what is the benefit you're getting out of it with the Tomcat thread against the virtual thread as a Tomcat. I hope this small tip will help you. Thanks a lot, and come back once again.